Hi and welcome to Design of Electromechanical System Experimental Demonstration. For my experimental demonstration, I would be talking about the Lorentz's force and the working principle behind the DC motor. Before we get into the experimental demonstration, let us look at the theory behind this application. Let's define the magnetic field surrounding a solenoid. We're using the right-hand rule, which states that if your thumb points in the direction of the current, fingers would curl, and giving you the direction of the magnetic field, which in this case would be clockwise. A solenoid would behave similar to a magnet having a north and a south pole and a field. Lorentz's force. Lorentz's force states that a charge Q, when moving at a velocity v placed perpendicular to magnetic field, would exert a force. So, in other words, a current carrying wire with length L, when placed inside a magnetic field, would exert a force. A simple working principle behind a DC motor having a north and a south pole and a current carrying conductor. Figure 2 over here shows a better representation of a DC motor where your thumb would be pointing in the direction of current, which in this case is pointing towards into the paper, and your fingers pointing towards the direction of magnetic field from north to south. Your middle finger will be pointing at the direction of the force that is being exerted on this current carrying conductor, in this case downwards. For experimental demonstration, we would require scissors, magnets, some crimps, safety glasses, enumerated copper wire, different sizes of batteries, a 3D printer where I was able to print out a 3D model, a simple 3D model, posted in case the magnet is not strong enough. We might need to move the height, change the height, a pencil, a sandpaper to clean out the enumerated surface, a screwdriver, and a plier. In this experimental demonstration, we would be showing the magnetic field that is being generated outside the solenoid using a neodymium battery that was obtained from a scrap hard drive. As I connect the positive terminal to the solenoid, I would expect the battery to move, and as expected, it did. Look what happened when I changed the direction of the battery itself. I would expect the magnetic field to be generated in the other direction and the magnet to move in a reverse direction. As expected, it did move in the other direction. Here what you see is a very simple DC motor. This is the frame made out of a 3D printer. I was quickly able to draft it. One can use any 3D modeling software. The magnet was obtained from a speaker, scrap speaker. This magnet is not very strong, therefore I had to raise the height using postage stamps. The crimps were used to support the cable to supply the power. I have 6 different batteries with increments of 1.5, and it can go up to 9 volts. One should take great care when working with this simple DC motor because it generates a lot of heat, and during testing phase I actually ended up melting the structure itself, so please do take care. Look what happens when I connect a 3-volt supply to my DC motor. Initially the motor doesn't move. It requires a slight jitter or slight push for it in order to move. As you can see, the battery is rotating perfectly. The DC motor is rotating perfectly. Look what happens as I increase the voltage, hence I'm increasing the current itself. Let's put it to about 6 volts and see the impact, giving it a slight push. You can see the speed of this motor actually increases. Putting back to 3 volts. With this experiment, we were successfully able to show that when a current passes through a solenoid, it generates a magnetic field itself, and when this coil is placed perpendicular to a magnet, it would generate motion, hence showing the Lorentz's force, hence proving the Lorentz's force.